in atoms. So we're going to see an atom or an element change from one element to another by removing protons and neutrons or electrons and things like that. Okay. Before we really get into it, I do want to do a quick review about nuclei and atoms because it's so easy to forget these terms. One term that maybe you don't recall from previous, oh dear, can't be crooked. Okay, nucleons. So nucleons refer to the protons and neutrons in the nucleus of the atom. Who remembers what atomic number is? Go ahead.
It's the number of protons in an atom.
Yeah, number of protons. I'll do pound sign, or I suppose some of you say hashtag, for number of protons. Okay, and then what's the mass number? Yeah, protons plus neutrons. Okay, so we are going to need to remember those. We're going to be looking at transformations of elements based on the number of protons, neutrons, and electrons. Isotopes then have the same number of protons, but different number of neutrons. I'm going to do P for protons. And N for neutrons. This is for an element of their type. So for instance, uranium is an element that has isotopes. Uranium-235 is one of these. And we can write nuclide symbols. So a nuclide symbol includes the symbol of the element, and then it contains the mass number, the uranium-235. The 235 is the mass number. So it will go top left. The atomic number is simply the atomic number of the element. So for uranium, that's going to be 92. Okay, essentially, the symbol and the atomic number are the same piece of information. So often you won't always see the atomic number. For uranium-238, the nuclide symbol would be the uranium U-238 superscripted, 92 subscripted. So again, this is the mass and atomic. Okay. Questions about that? You will need to be familiar with writing these nuclide symbols. This is how we're going to write our reactions. Nuclide symbol contains the symbol of the element, then the mass number, superscript on the left-hand side of the element symbol, and then atomic number sort of subscripted on the left-hand side of the symbol. Okay. So if we go back now, there are two different types of nuclear reactions that we're going to talk about, broad types. The first being the radioactive decay. Okay, and there are 6 different types of radioactive decay. Alpha emission, beta emission, positron emission. So make sure you know what those 3 different types of particles are. Electron capture, and then gamma emission. Gamma is a type of radiation, light. and then spontaneous emission. And then the other sort of broad category of reactions are nuclear bombardment. So this is a reaction where we have a nucleus and we take another nucleus and slam it into it. This is often the way that new elements are made with these bombardment reactions. We're going to spend most of our time looking at. It's actually fairly simple for writing nuclear equations and balancing them. If you can write your nuclide symbols comfortably, you can write these balanced nuclear equations. You do need to know the different particles that we are using in these nuclear equations. And so the first three on this table, neutron, proton, electron, you are familiar with, but we have given them nuclide symbols because this allows us to more easily write out nuclear reactions. So because a mass number is the number of protons plus the neutrons, a neutron is going to have a nuclide symbol of N for neutron, 1 in the mass number, and 0 for the number of protons in the atomic number. Okay? Proton we can write in two different ways. Typically, we'll write it with H for proton, and 1 for the mass number and 1 for the atomic number. Again, proton, you should be thinking, because the mass number is 1, that's the number of protons plus the neutrons. And if we know we have 1 proton based on the atomic number, that means we have to have 0 neutrons. Okay? The electron is given this symbol shown here, the 0 for the mass number and -1 for the atomic number. This one's a little bit funky because that's not a proton, that's an electron. Protons are going to have +1 charges, and electron is going to have a -1 charge. Okay. So that's just going to show up slightly differently. And then maybe the three that are less familiar are the alpha particle, beta particle, and positron. So an alpha particle is essentially a helium atom. It's going to have a mass number of 4, atomic number of 2. I'll typically write that symbol with the helium. I probably won't write alpha because I like having these atomic number and mass numbers present when I write my reactions. What about a beta particle? What do you think a beta particle is? So it has the same symbol as an electron, right? So it is essentially an electron. But we call it a beta particle for whatever, who knows who created that system, reason, okay? The positron is the opposite of an electron. It's like an electron, but it has a +1 charge. Okay. So essentially, we're going to have a reaction with products and reactants and products. And the mass numbers have to add up and the atomic numbers have to add up on both sides of the arrow, okay? So the mass number is going to equal the mass number and the atomic number is going to equal the atomic number. I did it again. Okay. In terms of radiation, alpha particle, beta particle, I do want to point out the gamma. So the gamma has no mass. Again, it is a photon. So it is a particle of light. All right, I want you to do one alpha emission so you can see the application of what I'm talking about. Keeping mass numbers the same on both sides of the arrow, and then atomic numbers as well. So alpha emission, you're going to take a nuclide or nucleus, and it's going to emit an alpha particle. Uranium decays this way. Not every element will decay in the same way. And we're going to talk more about that later. But let's take uranium-238. Okay. We know that, or you will be told that it decays by alpha particle emission. And the alpha particle, as we know, is the helium, 4 for the mass number, 2 for the atomic number. And I told you that the mass number and the atomic numbers need to sum up to the same numerical value on the reactant side and product side of the equation. So we can figure out what the other product is knowing that alone. So if we have 238 is going to be equal to 4 plus some number. What's that number have to be? 234. I'm starting with the mass number and atomic number, and we'll write in the symbol at the very end. And then for our atomic number, we're going to have 92 equals 2 plus some number, which is 90. Okay. And then we can use the periodic table, figure out what element 90 is. It's at the very bottom left side, and that is thorium. Okay. So in our decay of uranium, we give off an alpha particle, and the thorium is a daughter particle. And we'll continue with this next time.